This is conceptual review for test 3.7 to 3.10. I just wanted to basically, in a nutshell, give you everything you need to know about this section so that you can know what to study for the test. So 3.7 was about optimization. And what usually happened was we determined an equation for the quantity to be optimized. So let's say we wanted to maximize volume. All right, you'd have a volume equation. Volume is equal to something, 4/3 pi r cubed. I don't know, okay? And if the equation has more than one unknown variable, then we determine a second equation. If it only has one unknown, we can skip to step 4. So the second equation, solve for the unknowns. So again, we had an equation for volume, and maybe we had an equation for radius or something like that, or surface area. A lot of times it was surface area. So we had two equations. We had to solve and substitute. Okay, so we solve for one of the unknowns from step 2 and substitute into the equation from step 1. Take the derivative. So this is we're still in the derivative chapter. So you got to take the derivative and set it equal to 0. Solve the equation. You might have to factor. You might have to use the quadratic formula. Don't poop a brick. All right, just do that. And plug the solution from step 4 back into the equation from step 2 to solve for the other unknown dimension. Okay, so those were kind of like some of the problems we had. Remember, we had like that. We had 2 pins, right? And we had like a X, 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 Y, 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 Y. And so maybe we knew how much fencing there was, right? So our fencing would be 4x plus 3y is equal to some number, I don't know, 100. Maybe we have 100 feet of fencing. And we wanted to maximize the area. So like area is going to be length times width, so 2x times y. And so we're going to take the derivative of this thing, so we'd have to solve for whichever one we prefer, right? Like 4x is equal to 100 minus 3y. So x is equal to 100 minus 3y over 4. And then we would substitute that in for x. And now we have an area equation that we're eventually going to have to take the derivative of. Okay, so that kind of problem. And we had a problem where we had to, cut out the squares in a corner. Right. We had a problem, I think one of our example problems where you had a can with only so much material, right? And you had a radius and a height. Okay, so we had the equation for the surface area equal blah, blah, blah. And then we wanted to maximize the volume of the can, so that would be volume is equal to 2 pi. Let's see, what is the volume for a cylinder? Pi r squared h, I think. Anything tough, any equation that's tough I would give you, but if it's the basic equations like triangles and squares and circles, you got to know the areas for that. And you got to know the volume of a box, right? Length times width times height. Okay, but just look over all those problems. I suggest reworking every single homework problem, okay? You have time to do it. You really do. If you do that, you're going to do well. Okay, Newton's method. So Newton's method is just read over that sheet. That's all you got to do. Know what it is, and you can answer the question. I ask you one multiple choice question or true false question from it, just so you'll know what it is. Tangent line approximation. Tangent line approximation of a function. So that's where we did stuff like, we estimated, I don't know, like 2.99 cubed, right? So we formed an equation. We pick an easy point nearby. We take the derivative, get a tangent line equation, plug in x from the original problem into the tangent line equation, get an estimate. And then you get to check the answer in your calculator, okay? So, that'd be like, I don't know, what would be a good one? Let's try how about we want to estimate the square root of 24.9. Okay, so our equation would be, so step one would be y is equal to the square root of x, right? So that's going to be y is equal to x to the 1/2. What easy point do we want to pick nearby? Well, we want to pick a point, we want x is equal to 25, right? So y would be 5. X is 25, that's near 24.9. Y is equal to 5. So that's our point 25.5. And then step 3, we got to take the derivative, okay? So, y prime is equal to 1/2 x to the minus 1/2. So that's 1/2 times the square root of x. All right, and then we got to get the slope, right? So slope is going to be 1/2 times the square root of x here. So that's going to be 25. So that is 1/10. Okay, now you don't plug this one into the end, okay? We're plugging in this, getting our tangent line equation for a point nearby. So I'd have a tangent line equation, step 4, y minus y1, that's 5, is equal to 1/10 times x minus x1, 25. All right, so y is equal to 5 plus 1/10 times x minus 25. So y is equal to 5 plus 1/10 times 24.9 minus 25. All right, so I'm going to see what that is real quick. So right, that's negative 0.1. Okay, negative 0.1 divided by 10, because it's 1/10. So that's minus 0.01. So that's going to be 4.99 is our estimate. Okay, so that plug-in x was this step here, step 5. So is my estimate any good? Well, let's take the square root, 24.9, I'll raise that to the 0.5 power, square root, 4.989. That's pretty good. I'll take it. Only 1/1000th off. Okay, so that's how you do it. You can do that. You're all over that like a buzzard on a poop wagon. All right, then in 3.9, this next thing we learned was error propagation. Okay, so for error propagation, we wanted to form an equation from the shape given. Let's say it was a circle, a cube, square, sphere, whatever. We take the derivative, plug in x and dx into the equation from step 2 to get the propagated error, and present the answer as total plus or minus the error. Okay, so let's say we want to, let's say we have a circle of radius 10 and our measurement error is equal to, let's say, 0.02. All right, pulling this right out of my caboose here. Okay, so we know that the area is equal to pi r squared for a circle, right? So we need to get the derivative dA dr is equal to 2 pi r. So dA, our propagated area, is equal to 2 pi r dr. So dA is going to be 2 pi times 10 times 0.02. Okay, so that would be 2 times pi times 10 times 0.02. That's 1.257. Okay, so our area is going to be pi times the radius squared, right? So pi times 100. So it'd be 100 pi, let's say this is inches. We want to get to, don't get a -1 for the unit, right? 100 pi inches squared plus or minus 1.257 inches squared. That's not much error. Okay, so there's an example. You're going to be given a shape. You're going to have to form an equation, take a derivative, plug, plug, plug. Okay, so the last part, the business part, okay? So you want to review all your equations. So your cost equation, right? You have a cost is equal to blah, blah, blah. And then the average cost, you're going to take the cost equation, divide every term by x. Okay, so you might have to do that. Remember that revenue is equal to x times the price, little p price. Don't confuse little p price with big P profit. Profit is equal to revenue minus cost. All right, and so after that point, it's really, after you get your original equation, you take the derivative, set it equal to 0 like we keep doing, solve the equation in step 3 to determine the number of units, and let's say it doesn't ask you for units. It doesn't ask for X. Maybe it asks for price. Then you got to plug back in. Don't let step 5 get you. I've had so many students get punched right in the neck for this step 5 because they forgot to plug back in to get profit or price or cost, whatever. If it asks for units, that's X. X equals units. If it asks for something else, don't stop there. Don't circle the units. Plug it back in. Why am I telling you this? Why am I telling you this? Okay. This is what you should do. Maybe do this Sunday night whenever you get a chance. All right. Rework all homework problems. If you do that and you understand them all, I think you'll do well, okay? Remember, probably the most difficult problems are in 3.7, okay? So make sure you get all these right. If you have a tough one, it's in 3.7. Don't forget, you might have to factor. You might have to use the quadratic formula, okay? No brick pooping, okay? Don't do that. You know what to do. Use quadratic formula, factor it. You can do it. All right. I will talk to you next video.